just getting started.
All right. Welcome, Jacob. It's great to have you. Been looking forward to this a lot. You are the CEO and co-founder of ALA Engineering. Kind of give me a rundown of what that entails.
Yeah, so thanks for having me. ALA Engineering is agriculture leveraging automation. So we're building right now autonomous feed trucks. We've gone through multiple phases of driver assistance systems and then now to full autonomy. We're getting ready to roll out next year, actually going commercial. There's still quite a bit of work to do, but anything we can do to help the feedlot industry solve labor shortages, equipment cost issues, we want to do it.
Nice. Yeah, I mean, that's one of the big topics right now, I'd say, is the labor shortage, along with the flip side of that is people not wanting jobs to be taken away. So you're kind of finding that balancing act right now. You're kind of on that line. So how does ALA kind of feed into that with your autonomous feed truck?
So we really want to focus on not workforce reduction, but
Right.
workforce reallocation. So it's not that you want to get rid of employees on the feedlot. It's hard to find, retain, and properly train employees anyways. So definitely not replacing employees. We're just reallocating that labor into more skilled areas like animal health and lot management and that side of thing. So we're taking your most skilled laborers out of the feed truck itself and letting them focus more on animal health.
Right. Because at the end of the day, like running the feed wagon is kind of one of those monotonous tasks that if it can be eliminated, all your focus can go back into what they're being fed or even the health. And that's kind of the goal, right?
Exactly. And it's kind of weird because driving the feed truck actually takes a lot of skill and a lot of mental capacity. And so even though it's the most monotonous and kind of the worst job on the lot, it's with some of your most expensive equipment. It's one of the most crucial parts of the whole process. And it actually takes some of your best guys to do it right. And so if you're putting, untrained or relatively new drivers out there, you're getting equipment damage. You're being very fuel inefficient. Your feeding accuracy is way down. Your consistency goes way down. And you might not see those problems on day one with an inexperienced driver, unless there's a crash, of course. But, by weeks 2, 3, 4, you can really start to see issues with that inconsistent feeding and increased vehicle wear and tear. And so, it's some of your most expensive equipment. It's one of the harder jobs, and it's hard to retain people for it. And so it really is kind of the prime place to bring automation into the feedlot.
And it's also something that's happening twice a day, typically across all feedlots, right?
Yes. So all operations are different. I don't want to say that, this is how they do it, but a lot of the people that are most interested in and a lot of the pilots that we've done are that 2 times a day feeding. There are some that are trying to get actually closer to like 3, 4 feedings a day. That's another one of the cool things with automation is, it's kind of up for debate whether cattle will eat at night and consistency will remain the same. So we're actually looking at doing some pilots later this year, possibly early next year with night feedings and making sure that consistency and performance are held with night feedings. But that either opens up more smaller feedings for cattle or actually just shifting cattle schedules. And since the trucks can run 24/7, you actually can use less trucks to feed your entire operation by just spacing those out better.
Yeah. And I mean, getting into night feeding, talking about your autonomous truck, the sensors that you guys have, I've been baffled by. I saw you guys at an Ag Expo demoing it, and you guys had your camera system up on the big screen that you had there. Kind of dive into what that kind of looks like. I know that you guys have had several iterations of what sensors and cameras that you have to allow you to do the guidance systems.
Mm-hmm.
So where are you at right now, and kind of where did you start with it?
So the sensor systems that we're using, a lot of people in the more consumer side of the automotive and autonomous industry would call completely overkill. And that's because, ag and industrial solutions really require different sensor setups than a commercial or a consumer facing vehicle. And so, I mean, not to pick on anyone, but the most obvious example is Tesla with vision only. A big reason you go vision only is to keep costs down, because a consumer isn't going to buy a car that half the value is just in sensors. They want to buy a car. They don't want to pay for LiDAR sensors, essentially. And, you know, in a lot of situations that makes sense, but you can't operate in all conditions. You can't operate in really extreme lighting conditions. You can't operate in whiteout snow. Can't operate in heavy rain. Industry and ag require, you know, 24/7 operation through whatever conditions are out there. And so we really had to lean all in on bringing all of the available sensor types in, fusing those all together, and making sure that we can keep operating no matter what the weather throws at us. So we still have vision on board. So we actually run, there's 12 HDR RGB cameras. Okay. We run extreme HDR cameras so that they perform better in extreme lighting conditions. You know, throughout our testing, we've still seen that we can accurately detect objects and stuff, even at sunrise, sunset, things like that. But snow, heavy dust, heavy rain, cameras just don't work. So the next level up in sensors on the truck is thermal cameras. They're still vision based. They're still high resolution. But what they allow us to do is to continue operating through like rain, dust, and snow safely. Because even through those kinds of weather conditions, you can still read thermal signatures. And then we also have those on board for more animal health stuff as well. So we use those for navigation, safety, and for kind of the analytics side of things as well. Next step up is then LiDAR. And so LiDAR is a step down in resolution, but we run really high resolution LiDARs. So it's about as good as you can get in LiDAR.
Right.
But you get much better performance. Lighting conditions have absolutely no effect on the LiDAR. You get extremely good range, and you get actual ground truth data.
Right.
So in autonomous driving vision systems, everything is machine learning based. And so nothing is deterministic. There's always a machine learning model looking at something and saying, I think it's this, and I think it's this far away, and I think it's moving towards me at this speed. LiDAR, you don't have to think. You can deterministically know, you know, not necessarily what it is, but that there is something in my path moving towards me at this speed. And there's really, there's no chance for a machine learning model to err and, you know, get something wrong and cause a safety incident.
Because with the LiDAR, I mean, you're basically getting a feedback of distance, and that's the entirety of that LiDAR camera, right? That's what makes up the points that are being brought back to you.
Exactly. And that's how our main LiDAR sensors work, but we actually do run one forward LiDAR that's a little bit different. It's called an FMCW LiDAR, frequency modulated continuous wave. And it's special because it also returns a relative velocity value for each point.
Okay.
And so traditionally in automotive, you're looking way out on a highway or way out on a street. You need multiple LiDAR points on the same object over multiple frames to then be able to look at that and say, okay, that's what I think it is. It's moving in this direction at this speed. And if you're looking really far out or you're looking at fast moving objects, that can be difficult.
Right.
FMCW LiDARs really let you, if you have 1 point on something, and you know, that happens a lot because LiDAR is relatively sparse data compared to cameras. And so the further something gets away, the less LiDAR points hit it. And so with the FMCW LiDAR, if you have 1 point hit something and you get a return saying that it is, you know, coming towards you at the inverse of your current speed, you know that that's something just like going the same speed as the ground. So a parked car or a person or an animal, you know, something in the road. And you can know way out to start slowing down, or at least know that there's something there and you need to watch it pretty closely. But even more important, if something is coming at you really fast and you still don't have very many points at it, you can see that relative velocity might be double or triple your speed. And so you know that object is coming towards you. If you have very few points on it, you don't know what it is yet, but you know something's coming towards you.
Right. And you just wrapped up your month-long trial that was testing a lot of your sensors, and your end goal with that was 30 days continuous operation, no human intervention, correct? Mm-hmm. How did that go?
Went really well. And so that was kind of the last big milestone that we needed internally before ramp up for commercialization. And so having passed that, we're now moved into, a heavy hiring schedule. We're getting components and stuff ordered for the next couple of vehicles, and getting those on the production schedule. And that's really the last step we needed for internally knowing that we're going to hit commercialization, we're going to hit the target, and we're going to be on time.
Yeah, I mean it's that next step, and you guys are taking the next step right now. So going through the trial, I mean, with everything, you have some ups and downs. I'm guessing you guys, I mean, it was a month long. Did you have any weather? Like that was the big thing that I was curious about. I didn't know if you guys were going to get snow out there and be able to test the capabilities in snow while it's being continuously non-human intervention. So how was the weather for a month for you?
Yeah, weather always throws stuff at you. Last winter, we weren't nearly as far into level 3 operation as we are now. And so we had forward corner LiDARs on the truck last year, but they weren't actively used for navigation a year ago. So we got a lot of good data, made sure that we could actually still perceive the environment through the snowstorms, but that's as far as it went kind of last year. This winter, and especially through the 1 month milestone, we were actually using LiDAR for perception and navigation, and we did get a couple snowstorms. Nothing crazy this year, but still did prove the sensors can reliably work through these kind of worst weather conditions. Really something that we hadn't considered. We're usually worried about heat with LiDAR, and so in the summer, we got to make sure things stay cool. We got to make sure there's enough thermal mass to dissipate heat properly. Turns out to be a big advantage in the winter. So our cameras and our LiDARs and everything generates a lot of heat. So we had essentially no ice buildup, no snow buildup. Sensors stayed clean. Our sensor cleaning system still in development and wasn't active on the truck during that. And so just the heat of the sensors kept everything clean during those snowstorms. So that was something unexpected that we found was actually a plus for us.
Right. And it's always one of those things where you don't necessarily know those things are going to happen until you're out and about and testing it. And I mean, clearly that is a plus. I mean, if you guys can operate heavily during winter, I mean, that's probably when most of the feeders are not really wanting to get out into the feed truck, right?
Yep.
So, I mean, beyond that, I mean, we were talking earlier, but it's one of those things, especially with startups. If something's going to go wrong, it's typically when you're trying to present or trying to do something yourself. I mean, it kind of flipped for you. I mean, everything used to work properly when you were out there, but now that you're kind of changing roles, it kind of flipped. So talk about that.
Yeah. So the first couple of years of the project, I was still kind of that main technical role. And so I was the one demoing, to my co-founders and to sources of funding and to, other stakeholders in the project. And everything would always go super smoothly until those stakeholders are out there, and then everything, seems to go wrong.
About like going to the doctor, like except inverse. You always feel bad enough to go to the doctor, and then all of a sudden you're at the doctor, and you're like, oh, I kind of feel fine.
Yeah, kind of the inverse of the mechanic thing. I swear it's making a noise. It's not gonna because you're here. But yeah, for day 1, day 2 go great. Me and my co-founders go out to kind of watch the team and get the demo from them, and started to have some issues on day 3. It's just how it goes. There's always things. We found a couple of issues that we were able to fix really quickly. If we hadn't have pushed the system into such a hard trial, I don't think we would have found some of these issues.
Right.
Most of the time when you're just testing individual systems, and I know navigation works well, I know that localization is working well, we're just going to go and work on LiDAR sensors today. It's not until you put it into really harsh environments with no guardrails, and that's when you actually find the issues that really need solved. And so we're really glad we found them early on. We were able to then kind of restart the 30 days, finish it successfully, and complete that milestone.
But like you said, you have to put it into that situation in order to find those things that are going to break. Yep. And you want to find the things that are going to break before you hit market, right? Like that's the last thing that you want is the feeder to go out there and let it go and then have something break. So I'm glad you guys found it now, and then onward and upward.
Yeah, find it now while we have safety drivers and trained safety staff there with the vehicle, and hopefully not find it later when we're 2 hours away.
Right.
You know.
What was the kind of feeding schedule then for this trial?
So we only did morning feedings for this trial. Staffing mostly. We're trying to grow our Scottsbluff team, but it's a fairly slow process to find people in Western Nebraska that have, the techie background and the techie interest, but also want to be in the field working in ag.
Right.
It's hard to find, a software engineer that wants to work in a feedlot, and it's hard to find a guy that's used to working in a feedlot that wants to then take on the techie side of things.
Right. You're kind of really searching in the weeds there for that one golden egg, I suppose.
And the problem is we need 5, 6 of these people, and just finding one is extremely difficult.
Right. So why is the testing taking place out in Scottsbluff Gearing area?
So my 2 co-founders are Austin and Vince Aulick. They own and run Aulick Industries, and so we have a lot of infrastructure and team and everything out in the Scottsbluff area. They've also been working with feedlot companies, building, modifying, repairing, selling feed trucks for 20 or 30 years now. And so they already have the customer base. And so that's been our base of operations, and that's why most testing happens out there. Our next pilot actually is with the University of Wyoming, over in Lingle, Wyoming, just across the border. Also, again, great partner, but a big part is location to Scottsbluff. It is hard right now to actually test things out in eastern Nebraska. We can bring things down for a day or two, but we don't have the infrastructure or the team to support long-term pilots in eastern Nebraska yet.
Right, and just being located in Scottsbluff and your cooperation with Aulick, that's kind of where your background started, right?
Yep.
You were working with Aulick?
Yeah, so actually started on the IT team at Aulick while I was here in Lincoln doing my undergraduate. And that it's really crazy how everything kind of spiraled into this. But yeah, so started as the IT, kind of worked my way up through the IT team there at Aulick, and then chance conversation with my now co-founders. They had been working on advanced feedlot trucks for a while. So 2008, they worked on a prototype for a fully electric feed truck. It was a little bit ahead of its time. It was kind of before the Roadster, and so it was
really ahead of its time.
The technology was not there. The supply chain wasn't there. The comfort with electric wasn't there yet. Later on in, I think, 15 and 16, filed for a patent for GPS guided feed trucks and started to work on that a little bit. But the closed ecosystems for like auto steer systems, it's just very difficult to then take that technology and then reapply it to a feedlot specifically. So we really kicked off in 2019 with ALA Engineering. Just started fresh. Started with a brand new company focused 100% on the feed truck side of things.
And that's ALA. That's where you guys come in. And when I think about Western Nebraska, or I even think about South Central Nebraska, where I'm from, the biggest problem for us has always been, at least as of late, it's been connectivity. Mm-hmm. And I know that that's something that you guys have to work through and work with, is your internet connectivity.
Yeah.
How did you guys find your solution? Because I know you guys were working through quite a few things.
Yeah, we tried a lot. A lot of it is trial and error. Every networking company or every networking hardware company out there thinks that they have the perfect solution. And, it is a great solution under certain constraints, but it's not going to be the overall solution that we need. So we tried to come up with the silver bullet that would just solve the problem for every feedlot.
Right.
We thought initially that was going to be private 4G, 5G. It's called CBRS. Where you can actually host your own 4G or 5G network with your own tower, your own SIM cards.
And that would be on each individual feed yard,
each feedlot, yep. And so the problem was you needed a 4G, 5G core, you needed servers, you needed, server-rated power supplies, you needed redundant power. You still needed a good backhaul. So you could have a really good local network, but you're still struggling with, how do I connect to the internet? How do I connect to AWS? How do I connect to, How do I let customers connect in?
Right.
And it was just a really big cost. So I think that was 2020, early 2021, where we were really digging into the CBRS network. And just the upfront cost, we talked to customers, they weren't going to deal with it.
Yeah, kind of shocked at that sticker price.
We still kind of thought long term it would pay itself off, but that's a harder ROI to convince a customer of than the truck itself, because the truck is within. They know the trucks intimately. They know all the issues that are happening with trucks. They don't care and don't know about cell towers and how to maintain network infrastructure.
Yeah, that's a little above their typical pay grade. That's something that they've never actually wanted to dive into.
Exactly. There's no point in diving.
Right.
Into
it goes back to trying to find the perfect person out there. You don't have a software engineer that's working out in the feedlot, and you don't have a feedlot man that is a software engineer kind of situation.
Yeah, not every feedlot has like an IT infrastructure engineer on their team.
Right.
So that was kind of the first step that we tried. From then, just moved back to kind of standard 4G connections. A lot in ag, you're seeing more, LoRa and Zigbee and all of the low power, long range kind of IoT based communication systems. And if you're communicating with ear tags or tank sensors or weather sensors or low data volume sensors, those are fantastic.
Right. I mean, if you're only pulling information from there once a minute or once every 5 minutes kind of situation, that makes a lot of sense.
Yeah.
But where you guys are trying to do every second of every day of every hour.
Yeah. We're talking, we need 10 hertz communication with AWS control servers. We have, high data throughput needs. So the latency is too much, the speed's too low. And we're not trying to solve for like power constraints. Like LoRa was really built for long range, low power, low data throughput. And that's because you need really cheap hardware and you need really reliable hardware that's going to be able to run off a battery or a tiny solar panel for years. That's not a constraint we have. And so we had to find a different solution. We finally came across kind of the solution, and it is a modular system that allows us to determine the network based on location. And so we have an on-vehicle router that is multi-WAN capable. And so essentially what that means is we can, for each lot, pick and choose different internet sources or WAN sources that may be available there. Some new yards, especially like brand new or research-oriented yards, will have yard-wide Wi-Fi.
Right.
And if you built the lot with Wi-Fi in mind, that's fantastic. But if you have a legacy yard, you're not going to trench Wi-Fi infrastructure through your whole yard. Like that's not something most people are willing to do. And so Wi-Fi is kind of source one. Source two, if Wi-Fi or local infrastructure is not available, Starlink's a great option. Hardware is expensive. The monthly cost is expensive. But in an industrial or agricultural scenario where you're running all the time, it's worth it.
Right.
And so that's kind of that second really fast option. Then we have two different 4G modems on board. And so our traditional setup right now is Starlink as the main WAN source, and then just a standard cellular 4G connection as that secondary source. But then our entire fleet, just as an absolute backup, has an eSIM pooled data plan. That data is really expensive, and so we don't want to be using it.
Right.
But if Starlink and whatever 4G carrier we're using at that site both go down, there is that third option to fall back on that's multi-carrier, and things will keep running, just data costs kind of go up. And then the cool thing about that, both those 4G modems still do actually support the CBRS. And so once more feasible CBRS and local 4G, 5G network options are available, it's very easy to then swap that in.
Right.
So you can essentially, we can put the same hardware on every truck and just choose two good WAN sources, depending on what's available.
And so, I mean, you brought up how this is modular, but the truck itself it's not modular. You're not making a solution to plug and play with somebody's existing feed truck, correct?
Correct. That's another thing we tried early on and really quickly discovered we didn't want to do.
And why is that? Like, I mean, beyond the fact that there's many different types of feed trucks and there's many different operations, why wouldn't you want to just have something that you could plug and play?
So retrofit kits are fantastic, especially in infield and broad acre work. Retrofit kits are kind of the stopgap to get tractors and machinery that people own now kind of into the 21st century, and where they can start to take advantage of some of the autonomy or driver assistance or precision ag side of things. And so we still do actually run a retrofit truck. Our first test vehicle was just a Western Star 4700. And we still use it actively in testing. Right. But we've had to replace, probably 75% of the components on that truck. Completely new transmission, new controllers, new steering, new power delivery, new hydraulics, new air, new everything.
And that, I mean, from previous conversations that we had, but the reason why you've had to kind of go back and change all those things, especially like the transmission, you're driving at a significantly slower pace compared to what a human would operate at, correct?
Yes. So I guess there's two different things to note there. A feed truck itself just operates generally slower than a standard vocational truck. And so a normal feed truck, you're taking a standard off-the-lot vocational truck, maybe doing some slight modifications for air filtration and things like that to beef it up a little bit for the feedlot environment. But in its blood, it's still a on-highway vocational truck that's much better served as a dump truck or a concrete truck or a pumper truck. That's what those trucks were made to do. No one makes a feedlot specific chassis. And so you deal with a lot of brake issues and emissions issues and engine issues and transmission issues, especially because you're traveling so slow in some of the worst environments in ag with massive shock loads. You could be carrying 20 to 40,000 pounds of feed, with a driver that's been doing it for 2 hours. Like that is a scenario that happens, on a daily basis. And so the trucks themselves just aren't up to the task as well as we think they should be. There's also the thing to look at, it's kind of the iPhone versus the Android. iOS is supported for 5, 6, 7 years because there's 2, 3, 4 models a year.
Right.
Android, you get there's some now. My example gets worse every year as Google announces longer support for pixels, but you get support for a year or 2 years because there's so many models. It's such a diverse fleet of devices that it's just not economically feasible for security updates and OS updates to roll out to all of these devices. The same with feed trucks. If we were purely doing retrofit kits, we would have a lot more in supporting legacy vehicles than preparing for future vehicles.
Right.
Just because it's not doing the same task. You can't build muscle memory. You can't build a good, even just building a supply chain. You can't build a good repair supply chain.
Especially when every part is different for every truck.
Exactly. So we've switched to where we're building the truck itself.
Okay.
And so we can build out the infrastructure to support these trucks, the supply chain for these trucks, and then they're just built for the feedlot. Right. So rather than a standard transmission, everything's hydrostatic. So, the vehicle is limited to about 15 miles an hour, but in a feedlot, that's not a big deal at all.
Right. And your goal is not to be over the road. It's to be feedlot specific.
Correct.
Right?
These trucks will not touch a public road except on a trailer.
Right. And we had talked about that. I mean, the guidelines for over the road travel with autonomous is completely different, completely separate. And it's just something that you don't necessarily need to tackle.
Correct. Even not the autonomy part, just the DOT side of things, the levels that you have to go through to make a vehicle roadworthy isn't something we need for the feedlot environment. And then, you add the autonomy to it, and the open road is a way more terrifying, dynamic, and chaotic place versus the feedlot. On a feedlot, it's private property. everyone on that private property is a family member or an employee. And so we can, put proper training procedures through. Everyone that is anywhere near these trucks can have a full training on, how these trucks operate, how these trucks see you, how to emergency stop a truck. There's so many more things you can do in a private, off-highway scenario that just isn't possible on highway.
Right. And that's huge. When I think about it, once it's in place, you really shouldn't have to be transporting it, because that would be my biggest headache. Is the last thing I want to do is have to load something up on a trailer and take it elsewhere. But with the feedlot, the feedlot's not going anywhere. So keep it there.
Correct. Kind of the only problem with this setup is if you have satellite yards and 1 mil, we're not planning to support that kind of setup in the near future, at least. Long term, we can always come back and look at that. If regulations get more clear and the technology continues advancing like it is, eventually on highway becomes a possibility in certain scenarios. There is also, it's worth saying, a country road is different than a highway.
I mean, at the same time, like in my mind, it's having a tractor go down the road, and it's very comparable in my mind. But having the tractor go down the road, it's not like you're using guidance for that. You have somebody operating it at that point. Would that be in the future? Is that kind of like how you would think about it more than
possibly? Yeah.
But that's out of range, right?
That's a lot of engineering resources that could be, better allocated somewhere else.
Right. And especially right now, over the road is fairly, it seems like that stuff has been changing a lot. So it's not even like you have a set of directives that you have to meet right now and that you could start on and it would be the same a year from now.
Because it's not.
Because it's completely not, right? So, your brand new, the brand new feed wagon that you guys are building.
Yeah.
It's called Allen, right?
Yes.
Where'd that come
from? The ALA Navigator.
Okay.
Every autonomous company out there has something to call their driver. And so we didn't just want to call it the ALA driver.
Right.
We wanted to come up with something for it. But really, we talk a lot internally that this is, test platform 0, test platform 1, software version 0.9, 0.8, whatever. But we needed a way to talk about the package as a whole. So Allen represents the truck, the sensors, the compute, and the software, kind of the productization of the feed truck versus just the chassis version, the software version.
Yeah, it's bringing everything into a singular package, right? And then you guys have done a lot of talks around the neighborhood. Here in Lincoln, especially. I know. Have you guys been in a couple competitions as well? No, I can't remember.
Really, we've kind of kept out of it. We've tried to kind of stay in stealth when we could, and just keep our heads down engineering. We are kind of fully internally funded, and so we don't necessarily have the funding treadmill to hop on.
Right.
That those competitions, they're fantastic opportunities, but they take a lot of time. They take a lot of effort.
That they do.
Even just going to a couple shows a year. Like on the docket this year, we have Cattlemen's Ball, we have Husker Harvest Days, and we have the Nebraska Ag Expo. And then early next year, we got CattleCon coming up. That's only a couple events. But each one, we have to pull a truck out of testing, spend multiple days going through, routine maintenance, cleaning it up. If you're going to park a feed truck in the Nebraska Ag Expo, it can't just come straight off of the feedlot.
No,
it's
especially
not
not
liquid protein.
Especially not on that white carpet that they had you on this year.
Exactly.
Last thing I'd want to see is just dripping down or anything like that.
That was a 3-day process to clean that truck just for the Ag Expo last year. And so, yes, the labor is expensive to do that. Hauling it around, yeah, it's expensive, but the more expensive part is it's not in testing.
Right.
We're not finding bugs. We're not out proving to a customer in a pilot. We have to just actually take that truck out of circulation for upwards of a week to go to a single show. So it's very expensive, very time consuming, and anytime we need to do anything, even if it's not the truck, you're still pulling engineers off of their traditional workload, and
it's just time that could be spent elsewhere.
Exactly.
And I mean, you've got the engineering background where that's, I mean, I've been around you enough that you're kind of go-getter. Mm-hmm. Like you'd rather be just going, working. You got things to do. Might as well get it done. But I mean, those shows, they typically bring a good crowd, and a crowd that has an idea of what they're looking for. Mm-hmm. And you've probably been able to talk to quite a few feeders out there. What's their perception on what you guys are building?
Yeah. So, kind of like I mentioned earlier, we had the big customer base from Olix that kind of got grandfathered into the ALA side of things. And so we get a lot of cross promotion as the Olix Industries side of the business. We work with a lot of that team quite often. And so they talk about it. They're almost pseudo salespeople for us already. But just on the ALA side, we've been able to forge a lot of new relationships and find a lot of interested people from all over the place, whether it's the Pacific Northwest and Texas and Canada, Brazil, Argentina. There's people from all over that, reach out to us or meet us at shows that they need something like this in their operation. The problem is they needed it last year.
Right.
They don't want to have to wait till 2026, 2027, possibly 2028, because kind of that production build schedule is already pushed out there with all the interest we've kind of had already. And so it's really cool to meet all these people, but every time the demand goes up, it's just adds to our plate, knowing like we have more trucks to build and we're on an even tighter timeline now.
When you're talking to some of those new people that haven't necessarily been exposed to you guys, like what's their biggest question that comes to their mind? Because I mean, for me, like the first time I saw it, I was kind of just speechless because I didn't know where to begin. I mean, there's so many things that I could ask questions about, but like, when people see it, what do they ask?
The first question that is always asked no matter what is how much does it cost? We're in a time where we need to make margins in every part of the food supply chain as best we can. And the feedlot industry is not immune to that. Right. And so they need to keep costs down as low as possible. And so the question is always, how much does it cost? It's going to be an expensive unit. That goes back to, in order to support 24/7 operation through bad weather conditions, everything has to be overbuilt, over-engineered, over-tested.
Right.
If you needed a feed truck that only operated in 95% of weather conditions, we could have had that to you last year. It's that last 5%.
Some people probably would have taken that at that point, but
they would have taken it at first until that 5% happens.
Right.
If I got a call at 9 a.m. on a Sunday because there's 10 inches of snow in Calgary and the truck's not working, that is a make or break situation for a company. Even if the customer thought that they knew that was going to be an issue, when it happens, it's a whole different story.
Right, and that's where you guys have been just working. I mean, you guys are over engineering, you're over testing, you're doing everything that you can to make sure when that first product goes out to the first customer, it's ready.
Yes, because it's that last 5% that's really, really hard to solve for, but it's the most important 5%.
So going into this next year, I mean, you just finished your trial. The main manufacturing is probably going to start kicking up. Is that correct to say?
Yes. So we're still building testing units right now. And so we haven't officially kicked off production of P units, we call them, or production units. But that is scheduled to start early next year. And so we're already to the point where we're having to start putting POs and start allocating funding towards hardware needed for production series trucks, even while we're still building testing trucks.
Another thing with that, I mean, just trying to get the right parts. I mean, supply chain, basically since COVID and since I've been working with a lot of tech startup companies, like supply chain has been one of the biggest issues. It seems like, okay, it will be here in a month, 6 months down the road, things are coming in. How have you guys been dealing with that?
We've been lucky that even though we've dealt with a lot of supply chain issues, we've always been able to keep things moving.
Right.
Getting into production, so 2026, 2027, it's going to be really critical that we get supply chain in check. The last year has even been pretty rough. We have lots of shipping issues with ports and strikes and material shortages, and now tariffs and price increases. Managing all that is difficult, but we've been able to get through it because there's so many things to do. If we're waiting on one part, we can always put another part in. And so a good example of that is like front axles. Front axle gets delayed by 6 months. Let's rip one off of one in the junkyard, throw it in, and run it for 6 months until we get the real axle in, because it's so much more expensive not to be testing. No matter what it takes, you got to get the truck into testing, because that is the most expensive thing. You got multiple engineers, time, you have timeline, and your roadmap just shrinking and shrinking if a truck's sitting around. So anything to get that truck moving. And we've been pretty lucky. A lot of things are getting better now with sensors specifically, where you have multiple vendors available. And so all of our sensors, except for thermal cameras,
that's the one bugaboo.
Really, FLIR only makes the thermal cameras. But for all the other sensors, there's other options that we already kind of have emergency contingency plans in, that this sensor will fit. We can swap in this sensor, change some configuration files, and get the truck running out. So even though our testing units have slightly different sensor stacks, we're only inventorying right now kind of one version of each sensor. But we have, it's as simple as like we have brackets made to retrofit the new sensor type on the old vehicle, just in case that sensor that we can't source quickly dies. And so a lot of it is just planning, and you know things are going to break, things are going to need R made, and making sure that you have on hand, even if it's not the same part, you have something that you can swap in that will provide the same or better performance.
Nice. I guess one thing, you're testing here in Nebraska, heavily out in Gearing. You're located, you're officing out of here in Lincoln. Mm-hmm. Why is it important to be in Nebraska? I mean, we're one of the top beef states in the nation. So why is that impactful for you?
So being in Nebraska, kind of the biggest reason, flat out, we are a beef state. And so if you want to run a feed truck company, this is probably the best state to do it. We're centrally located. There's potential customers, Pacific Northwest, Canada, Texas, South America. Nebraska is at least roughly in the middle. Right. It's not like we're trying to service the Pacific Northwest from Florida or something like that. Secondly, just my co-founders and myself, we have a long history in Nebraska. Industries has been running since 1952 in Scottsbluff, Nebraska. Just really deep rooted. It's a good workforce. It's a good state to be in. It's a good state to manufacture in. We have multiple office locations to help with, technical talent sourcing, or, even just making sure that you have engineers with different backgrounds, stuff like that, so that you can solve issues together. So you got to spread out a little bit. Right. You can't just kind of run the whole operation in Scottsbluff, Nebraska. But Nebraska as a whole is kind of the best place to run a business like this. Right.
And I mean, you make several trips out to Scottsbluff almost on the week, right? So, I mean, it's a 5-hour drive from Lincoln.
It's a 5.5 hour drive.
5.5 hour. But realistically, it's doable. And once you're out there, you can work, you can get things done, but also you can be here in Lincoln. And being here in Lincoln, I mean, there's tons of resources. You're officing out of Innovation Campus here and the Combine, correct?
Correct.
You were / are in the incubator space for the Combine, right? Yep. How has that been?
So, the resources on this side of the state, on the engineering and innovation side, far greater than kind of what's in Scottsbluff. And so we have the manufacturing and the shop space and the pilot lots and all that in Scottsbluff, but we needed resources here in Lincoln. We've been at a couple of different offices in Lincoln. You know, we've been at Fuse, we've been here on Innovation Campus, we've been remote during some parts of COVID. But just finding a place here, having the resources available has been a huge help. It's just kind of an environment thing. If you're in the environment of ag engineering and you're just physically nearby the right people, it really does help the team.
Right. And how has the kind of talent pool been? I mean, I know that there's a huge push on East Campus here at the University of Nebraska-Lincoln for getting more ag engineers specifically. So how has been the talent pool, I guess?
It's getting better. I would say where we were at as a company 3-4 years ago, the talent pool here was phenomenal. We weren't doing all of the crazy cutting edge autonomous vehicle stuff. It was more standard software engineering and the ag engineering side of things. As we moved our tech stack and our hardware more to the cutting edge, the talent pool in Lincoln got kind of harder to source for. The people are here that have the want to do it. It's the experience. The people that have experience with this stuff, the universities that do projects with this kind of thing, you're talking CMU or you're talking places in California, you're talking MIT. And so to get someone straight out of college or even just, relatively early in their career with autonomous vehicle experience is pretty much impossible in Lincoln. But the talent pool is getting a lot better on general robotics. There's at least more of a push towards general robotics education and kind of robotics majors at UNL. And so we're really hoping the next couple of years can really ramp up. But for senior and staff level engineers, we kind of have to bring in that talent from elsewhere.
Right.
And we have to build that up before we can start hiring more junior engineers here to kind of grow those engineers into autonomous ag engineers.
Right. And one thing, like the reason why I ask is because there are a lot of those going to be engineers that are going through the UNL program right now, but they have the kind of background in the feedlot. They either work there for a summer or hell, they're from a feedlot to begin with. So those people are coming up, but you're just not to the place where you can hire someone that green.
Correct.
To kind of introduce them to autonomous.
Yep. We got to build up the senior team to be able to kind of grow and mentor and train the less experienced, newer engineers.
Right. And kind of walk me through what your team looks like right now.
Yeah. So our team is split between 4 different places. And so we got Scottsbluff, Nebraska. That's our manufacturing, testing, and integration. We have a phenomenal team there. I've actually slowed down my trips a lot because I don't have to be on site so much because we have such a fantastic team over there. We have Lincoln, and that's kind of our general software engineering. We're trying to recruit more out of the university. We're trying to utilize the resources available here in Lincoln. We're growing a small team in Malaysia, and we're growing now a medium-sized team in Cairo, Egypt, actually.
I know that there was a reason behind Egypt. Why target Egypt?
So we didn't start thinking that we were going to target Egypt. Early on, there was just some odd jobs that I needed help with. Didn't have time to complete some of these, and so we found an engineer in Egypt, and he just started doing kind of odd jobs for us. Come to find out, he's an absolute wizard.
Oh, really?
Most of the team literally just refers to him as wizard. It's kind of funny, but we found the right person, and then found out that the talent pool there is really close to what we need. The agriculture side isn't there, but the automotive side is. So one of Egypt's biggest talent pools is actually automotive software engineers. And so there are a couple really big companies in Egypt that employ a ton of software engineers, embedded engineers, functional safety engineers. for the automotive industry. And so companies in Egypt, they, do work for Ford, GM, Audi, Volkswagen, everybody.
Right.
And so the universities there and the talent pool there have been pushing more of the embedded software engineering side of things, but in the past 5 years, a lot of the autonomous. And so we're really easily able to source talent that has 5-10 years in automotive, maybe a couple of years in autonomous, or even just straight out of university, people that did their master's program on autonomous driving, have boots on the ground experience with it. And so that has kind of made us relook at how the business structure is. And essentially we kind of have two parts of the business. We have one general autonomous vehicle side of the business, and we have the feedlot focused side of the business. And so a lot of the underlying tech and sensors and perception and localization is really built as general autonomous that could be applied to construction or industry, ports or ag. And then kind of the US side of the business is really focused on taking the self-driving tech and how do we specify it and use it for the feedlot industry.
Yeah, because going back to finding an engineer that has the feedlot experience or a feedlot manager that has engineering experience, it doesn't really work. How has that worked out with working with the people in Egypt? They probably don't have that feedlot experience, but are they able to kind of grasp easier since they have the autonomy background?
Yeah. So one of the big things is trips. You got to bring remote engineers on site. That's really the only way that the distributed engineering team works, is if you have dedicated on-site time. The second part is with robotics and autonomous driving, so much work is done in simulation that we can we have a good data pipeline down where we can go and perform testing in a feedlot in Western Nebraska, have that entire data recording, 1, 2, 4, 5 terabytes uploaded to a server and available in Egypt within, 48 hours.
That's impressive.
And they can legitimately use the data and run the simulations and continue to work with it as if they were there. The autonomous driving side has been more focused on road. And so I wouldn't say it's harder to get the engineers ready for the feedlot. I would say it's more like the tooling and infrastructure that's open source and available that is industry standard, trying to get it to focus on a feedlot where you have less well-defined roads and, just different obstacles and different things to worry about than on road. That's more of the challenge. Engineers haven't figured out.
Right.
So,
there's got to be some decent stories of bringing somebody to the feedlot that's never seen a feedlot before. It can be a shock. The first thing that everybody runs into is the smell, right?
Yeah.
But there's got to be something there. What's their typical reaction once they get on site?
Really, let's get busy.
Okay.
We haven't seen anything, weird. It's been more as we bring people in from the tech industry or vendors and sensor manufacturers and stuff. We bring them to the feedlot, and they're the ones like, oh my,
A little off put by it.
You bring engineers on, and they're just like, what are we doing? Let's get busy. And I guess another part of that is because you do so much work in simulation, they feel like they've already been in that feedlot for months.
Right, they're already engrossed into it, right?
They're staring at the camera feeds. They're staring at the LiDAR feeds. Our engineers know that feedlot better than most of the people that work at the feedlot.
Right. They're going through it with a fine-tooth comb
Exactly.
at that point. They know every bump, every nook, every cranny.
Yes.
That's awesome, though.
They can recognize that bump wasn't there yesterday. Like, that's kind of the level that, everybody, even the team here in Lincoln, they work so much with data from feedlots in Western Nebraska. Even the Lincoln team really goes down once, maybe twice a year to Scotts Bluff, but they know that feedlot intimately.
Right. You mentioned it just a little bit, but you are working with tons of data.
Mm-hmm.
One trip, you said 4 terabytes, basically.
Yeah, well, that's kind of more of the full day of feeding.
Okay, so a full day of feeding, roughly 4 terabytes,
Yep.
and that's every day. What's your solution for that? Because, I mean, I'm working with a small server with only 12 terabytes of active storage, and that's more than fine for me for media production.
Yeah.
I can't imagine working with 4 terabytes every single day.
The real industry standard solution costs multiple million. We we don't run that.
Right.
Early on, before we decided to build a lot of this ourselves, we did go and do the smart thing and quote out like, okay, this company specializes in this company specializes in this. What does it cost for you to take a feed truck and kind of retrofit it so that it has essentially an API where we can control it? Or you have a solution for data storage and management. We went through that whole process. And if you are Waymo or Tesla or, these companies that are running hundreds of test vehicles, and each one of those test vehicles is, generating terabytes of data every hour, every day, you do need a absolutely ridiculous way to manage that data. We have been able to build a data pipeline that can manage it mostly with kind of small, medium business NAS and server class hardware rather than, industry specific enterprise grade solutions. And so a big thing is we don't have to store all of that data in perpetuity.
Right.
We really do keep probably less than 40 or 50 terabytes of training data at any point in time, because we can get in, use it, actually validate what happened that day in testing, go through and see, okay, this bug occurred. What's the actual fix? We can use that data to troubleshoot it, but we don't need to keep all of that data forever. So a big part of that is extracting the useful data that you want to use later, whether that's images for machine learning training or, specific chunks of the data for really interesting scenarios or edge cases that we found. But we don't need to just store, hundreds of hours of sitting there at the mill getting loaded.
Right.
And so it's a constant challenge to deal with that much data. But we've been able to just kind of internally come up with decent solutions to do it. A big part of that is not necessarily transferring that data all the time, doing what we can with the infrastructure in Lincoln or in Scottsbluff, remoting into virtual machines or machines there locally to use that data rather than trying to, every day transfer terabytes of data internationally. And sometimes it just really comes down to, in the feedlot specifically, if we need to get, data off of the truck, Starlink's fast. It's not that fast.
Right.
Actually, what do they call it? A sneaker network?
Okay.
Put it on a portable SSD, drive it into the office, plug it into the NAS.
Okay.
So we really do have a sneaker net where we're moving around ridiculous amounts of data just on drives between locations, because your data, your like internet backhaul isn't made for that level.
Correct. Well, looking forward into 2025, what's on the agenda?
So starting that pilot with University of Wyoming, getting into another pilot in Western Nebraska where we're focusing more on, we've done the no human intervention, but we want to get into more, it's not our engineer running it at all. We're handing that tablet over to someone on the yard.
That's awesome.
And being hands off. So we have a 30-day run of that, and that's going to be scary. No engineers, no remote engineers on a call. Our guys not standing there looking over the shoulder. The tablet's in the hand of the feedlot operator. They're the one running the whole show. So that's a big step, scary step, but we're ready for it. We got a couple shows this year. We got Husker Harvest Days, the Cattleman's Ball, and Nebraska Ag Expo. And I believe we still have one pilot slot open, just recently opened back up for later this year. I think we already have a couple leads on where we're going to end up going. So those will all still be in Western Nebraska or Eastern Colorado.
Nice. And then kind of what's your outlook on the next 5 to 10 years? Where do you see the feedlot as a whole, and then where do you see Alan plugging in?
So the feedlot is getting more technologically advanced. We've even been in talks with different people in different industries about how they're bringing more connectivity or technologies to the feedlot. There's big pushes now for fiber backhauls to feedlots. And that would be, a phenomenal step forward in the whole data and networking side, not just for us, but for every technology company that wants to be a part of any feedlot.
Right.
That's going to keep getting better. Feedlots are consistently looking more at innovation. And so we're seeing a lot more large feedlots with dedicated innovation teams, where their job is to figure out how do we make this more efficient? How do we bring in new technologies and new solutions? And even smaller operations, we're seeing people more open to high tech. We're seeing more, young people taking over the family operation and saying, I can't keep doing this with labor. What's the logical next step? The beef industry is going to keep growing. The demand is going to keep growing, and the labor market's going to keep getting worse. And so we think we're in a really good spot to start production in 2026 and start that rollout over a couple of years past that. Really, for us, our solution is feature complete, and so we can fully navigate, feed, handle safety critical situations, and all of that. This next 2 years is really about safety certifications and just getting it into as much testing as possible to find all the different edge cases and just really hardening the system, getting it ready for full production. Once we hit production, we can then start looking at kind of the animal analytics side of things, which also excites me. We have terabytes of data that get thrown away after we use it to navigate. We can use camera sensors to detect hotspots on cattle. We can use LiDAR sensors to detect bloat or track gait or identify cattle with cattle facial recognition. There's so much more we can do beyond just feeding with the sensors and compute that we have to have for safe navigation. So really the next 2 years is about hardening the system, passing safety certifications, and getting to production. And the 3 years after that is bringing more features that the feedlot wants.
Yeah, I'm excited to see what that ends up being because, I mean, if you can, it's just like having a pen writer at that point. And even pen writers aren't necessarily the greatest at identifying those things. But if you can have the thermal camera determine whether the animal's running hot or not and be able to pull cattle that way and get them into the sick bay, more power to you.
Exactly. Pen rider is still a very crucial spot in the feed yard. We want more of the drivers to be pen riders.
Right.
We just want to be passively all the time trying to sense symptoms and stuff before the pen rider themselves would be able to notice it. We want to catch things early, deal with them quickly, and really just prioritize health.
Right. I mean, with the thermal camera, you're probably noticing things 24 hours in advance before the pen rider can notice if they're acting lame or anything like that.
Yep.
So that's very exciting. I'm looking forward to talking to you again when you get to develop that stuff.
Yeah, for sure.
Sweet. Well, I want to thank you. I'll let you get out of here, get to your next meeting, but thank you for coming on.
Yeah, thanks.
We're just getting started.